Okay, this is the hardest kind, and the way you're going to know that you might have to do it this way is when you do derivatives and integrals of these two things, they just keep repeating. Okay, they never quit repeating, so you would have to do kind of use substitution forever, except there's kind of a little trick here. So I'm going to leave this here, and I hope we remember that the integral of the integral of d du, no, u dv, is going to equal uv minus the integral of d du. So this is our formula right here. That's a u. All right, and we're going to let u be, and I'm going to say u1 because I got to keep repeating this because it's not going to be done after 1 because these things repeat forever. It's going to be my exponential e to the 3x, and dv is going to be the other part, which is cosine x dx. And when I do the derivative of u, my first derivative of u is going to be 3e to the 3x, because you got to do the derivative of the exponent. And my integral of dv is v. My integral of cosine is sine x. So I stick these in here, and it's going to be uv. So it's going to be this times this. So I got e to the 3x sine x minus the integral of v, which is sine x. And I'm going to move that over, sine x, du, which is this thing, and I left the dx off there, so this is 3 e to the x sine x dx. So if you look here, we're going to have to do use substitution again, because we still got two parts. So we're going to have u2 is going to equal 3e to the 3x, and dv is going to equal sine x dx. So integral of dv is v, integral of sine is negative cosine x, and the derivative of u, I should have put a 2 here and a 2 here, and you should have had 1s, because they're all the first one. And then the integral of this is going to be 9e to the 3x dx. I'm going to plug this in. Now, it's minus this whole thing, which makes me wonder if I made a mistake earlier when I had the one repeated. I'm not sure if I put the whole thing in parentheses, but it's minus this whole thing over here. So it's uv, so there's u, there's v, so I've got a negative 3, because 3 times negative 1 is negative, e to the 3x dx. Because, oh, no dx. And then cosine x. And then it's minus the integral of u, which is this, or sorry, v, which is this thing. So it's a negative. Okay. And then we got our v, which is this thing, cosine, times our du, which is this part. So I'm going to put the 9e to the 3x first. I got to move this over. I'm going to move my du out of the way. And then I got my v part, which is the negative there, and then this cosine x. And then there's a dx in this part. Okay, now if I didn't put the parentheses or brackets around the last problem, I did this more than once, I might have got a sign wrong. So you probably ought to check that. So I got e to the 3x sine x. And then I got minus a negative. So these two negatives make a positive, 3e to the 3x cosine x. And then I got this negative that comes over here with this negative, which is a positive, and then it's times that negative right there, which is still a negative. And I'm going to move the 9 with the integral. That negative 9 I'm putting in front, because that times that's a positive, and then that's still a negative. And then I got e to the 3x cosine x dx. Now I kind of wish I would have kept writing this part down, because I am almost to where I can do a little trick here. This thing over here has not changed. Now I could keep going, but the problem is this stuff is just going to keep repeating. But if you look at this integral of e to the 3x cosine dx, that is exactly this integral of e to the 3x cosine dx. In other words, but just like variables, those are like terms. So what I want to do is I'm going to add and get my like terms over here on the right side. So I'm going to add 9 of these integral e to the 3x cosine x dx over here, which this all goes away, that's 0. And I'm going to add 9 of them over here, e to the 3x cosine dx, which is going to give me 10 integral e to the 3x cosine x dx. And that's going to equal these other two parts right here. So I'm going to rewrite those parts down. And now we are almost finished because you remember, we want this integral part, but not the 10. So we got to get rid of the 10. And well, that 10's multiplying by that. So we are allowed to divide each side by 10. And these 10's reduce. And this thing over here is my answer. So the integral of what I was looking for is this thing over here. Now you can put a 10th in front, or you can leave the 10 in the bottom. It doesn't matter. But this is the answer to that problem. So it is a hard problem. And again, when you keep doing derivatives and integrals of e and trig function sine cosine, they're going to keep repeating. So you could write your answer like this or like this, either one, and you're done. So pretty hard problem. Good luck, and I'll see you next time.